Today we're going to start solving square root equations, and before we do that, let's remind ourselves what the parent graph of a square root graph looks like. F of x is equal to square root of x. So a rough sketch of it looks something like this. It's a half sideways parabola. Now before we solve, let's explore what this one looks like. Let's change it to be, I'm gonna rewrite it in a different way, or maybe not rewrite it in a different way, but rewrite it a different version of this, let's call it. Let's say I have y squared is equal to x, and I wanted to isolate y. If I isolated y, I would have y equals plus or minus square root of x. So this is different than the f of x we have on the left, because I had to square root both sides. In this case, the square root wasn't given to me. So when I have it like this gives me two functions. It gives me y equals square root of x, which we have already graphed on the left side, but it also gives me y equals negative x, negative square root of x, that's the reflection. So it's gonna give me sort of the other half of the graph that isn't there. So because of the way square roots and their equations work, sometimes we're gonna get multiple solutions. So like a solution is where graphs intersect. So maybe there's another graph there. Maybe it could be a line. Now if I look at just the blue graph, that's just the square root. There's only really one solution. However, because of the way square roots and squares act, sometimes we'll get another one. Notice this is in the dotted part, which is not part of the original square root. So when this happens, that extra point is called an extraneous solution. So we're gonna see how those occur algebraically today. Let's go ahead and get started. The domain of a square root function includes all values equal to or greater than 0, or in interval notation 0 to infinity. So from seeing our little square root graph here, we can see that that is happening. It starts at 0 and then keeps going to the right to infinity. When solving square root equations, we have to check for extraneous solutions. To solve square root equations, follow these steps. Step 1, isolate the radical term. Step 2, square both sides of the equation. Step 3, solve for the unknown. Step 4, check for extraneous solutions. Now before we go through and follow these steps, we do also want to remember this important property. If I have the nth root of x, that is equal to x to the 1 over n power. So how is this useful? Let's zoom in on here. If I have a square root of x, I want to remember there's an invisible little index here. It's a 2. So if it's the second root of x, that's the same as x to the 1/2. So I want to recognize that when I see a 1/2 power, that is the same thing as a square root. So we'll see that come up a couple more times later in this classwork. But let's go ahead and go through this example. Solve the equation square root of x minus 3 plus 4 equals 9. Step 1, isolate the radical term. So the radical term is the part that has the root. So when I look at this, the radical term is square root of x minus 3. So I'm going to write that down, square root of x minus 3. So I want to think about, well, what's next to it that I can get rid of? I'm going to subtract 4 on both sides. So by subtracting 4 on both sides, that's going to leave me with now my radical term alone. Square root of x minus 3 is equal to 5. Step 2, square both sides of the equation. So I'm going to go on both sides and square like so. The square and the square root will undo each other so that we are left with x minus 3 on the left, and we will get 25 on the other side. And then finally, step 3, solve for the unknown. So to continue, we're going to add 3 on both sides, and x equals 28. Okay, we're not quite done yet, so I'm not going to box that answer. Step 4. So we're not quite done yet, so I'm not going to box that answer. Step 4 is to check for extraneous solutions. So I'm going to substitute the solution I got. Substitute x equals 28 in the original equation and simplify it using PEMDAS order of operations. So the first thing I'm going to do is simplify what's inside my radical. And I'm going to have square root of 25. Then I want to simplify my radical. And that is going to give me 5. And then I'm going to go ahead and add it together. 9 equals 9. That is true. So 28 is not extraneous. It is our only solution.